Okay. Um, hi, my name is Chris, and I am Aiden and Elizabeth's dad. And if I can get into my slideshow here, these are some of the things that we're going to talk about today. Going to tell you who I am, and then we're going to learn a lot about the weather, right? And so once we get into this, if you guys have questions, please feel free to let me know because there's a lot of information coming here. So, a little bit about me. My name is Chris, and like I said, I'm Aiden and Elizabeth's dad, and I'm the fire chief in the village of Maple Bluff, which is a small town here in the state of Wisconsin. And so I've been in the fire service for about 20 years, and I'm also a certified weather spotter for the National Weather Service. And so I love the weather because I think it's super interesting, and there's a lot of science behind weather. So it really ties into all of the stuff that you guys have been talking about and up to this point. So hopefully we can have some fun. So what is the weather? So when you go outside and you look up in the sky and you see that it's a beautiful blue sunny day and it's wonderful outside, that's weather. But also, if you were to go outside and it's super duper hot, that's weather. And if it's raining or snowing, that's weather too. And so weather is essentially anytime you're outside, it's the world that we live in. It's the air around us. And so what we're going to do is we're going to talk about what causes it to be sunny and what causes it to rain and what causes it to snow and things like that. So when we describe our weather, that actually takes place in what's called the troposphere. So on this slide that we have here, if you look way down at the bottom, that's the planet Earth. And you see that there's some clouds that are raining on top of the Earth, and there's a volcano, and then there's an airplane flying overhead. And so that's the area where we live on planet Earth, and that's called the troposphere. And the troposphere is the bottom layer of our Earth's atmosphere. So the atmosphere is like a bubble that completely surrounds planet Earth. And that bubble actually keeps in all of our air that we breathe, but it also keeps the rain clouds and dust particles and all kinds of things, right? So in the troposphere is where almost all of our weather is going to take place. Okay? So let's talk about that. So the troposphere is where our weather takes place, but why do you think that is? Well, the Earth has gravity, right? And so gravity holds us to the ground. And in addition to holding us to the ground, gravity also holds all of the molecules and particles in the air close to the ground as well. And when the Earth's gravity is holding those molecules against the ground, it's creating pressure, right? And so all of those molecules being held against the ground, there's different air pressures. And that air pressure is actually called wind. So when there's high air pressure in certain areas where you might live and low air pressure in other areas, the high air pressure wants to continually move to where the low air pressure is. And that's what causes wind where you live. So if you see in that picture, the grass is blowing and the clouds are blowing, right? And those are just little teeny tiny little air molecules that are blowing through the sky, even though you can't see them. So those teeny tiny little molecules are what make up clouds, right? And so clouds are actually little bits of moisture that evaporate up into the sky. And when those little water moisture molecules evaporate up into the sky, they bond together, and that's what creates a cloud. So when you look up in the sky and you see beautiful, big, fluffy clouds, those are actually made up of different little water droplets. And so what a cloud does is it absorbs as much water, those little water droplets as it can. And when it gets full, right? So think of a cloud like a sponge, right? So as that if you have an empty sponge, Aiden, is an empty sponge heavy or is it super light?
It's heavier because of all the water in it weighing it down.
Yeah, so it starts super light, but as it absorbs water, right, the sponge gets heavier. And then if you were to just squeeze it just a little bit, a whole bunch of water falls out of it. And so if you think of a cloud like a sponge, it absorbs a whole bunch of water and it gets full and full and more full. And then eventually it can't hold any more water and it dumps all that water out the bottom of the cloud. And so that's where our rain comes from. Well, what happens if that cloud gets super full of water vapor, but it's cold outside? Do you think it comes down in rain? Or what are some other forms of precipitation that we might have?
If it's really cold out, what happens? Say real loud.
No.
I heard somebody say snow. That's correct.
Sleet and ice.
Yeah, sleet and ice and snow. Yeah, those all happen. Great job. Those all happen when the cloud gets full and it drops its moisture and it's cold outside. That's where we get snow, right? Got to get back to my correct screen.
It has to be
So, yeah, go ahead, buddy.
32 degrees, right? Or 38
Yeah.
degrees to form snow.
32, you were right. Yep, so 32.6, I believe. Good job, Aiden. So if the atmospheric temperature on the ground is about 32 degrees or less, it's going to fall in the form of snow. And if it's 32 degrees or above, that moisture is going to fall in the form of rain. So if you live in an area where it gets super cold or it's 30 degrees or 32 degrees or less, the precipitation that falls out of the clouds can be snow. And if you live in an area where it's warm, Southern California, for instance, you don't see snow very often unless you're way up in the mountains because the ground temperature isn't cold enough for that moisture to turn into snow. So on this slide, there's a whole bunch of different clouds that you might see. So on the far side, the cumulonimbus clouds, those are those ones that I was saying that collect all the rain. And sometimes cumulonimbus clouds can climb way up in the sky and they hold so much rain they can produce a thunderstorm. But there are other clouds. There's a little one on the bottom that's all fluffy and white. Those are cumulus clouds. And those usually look like fluffy cotton balls. And when you see those in the sky, you pretend that sometimes they look like dogs and cats and animals, or they look like faces sometimes. And then there are stratus clouds, which are super wispy and long and drawn out. And so when you look in the sky, you can try to identify different types of clouds. And they're not all the same, and not all of them can produce rain showers, and not all of them can produce snow, and not all of them can produce thunderstorms. So here's another picture of all the different kinds of clouds that there are out there. So the big one in the middle, that's cumulonimbus. Those are the ones that can produce a thunderstorm and drop rain. And then there are nimbostratus clouds. Those are the ones that can also produce rain and thunderstorms and snow. The rest of them don't get thick enough or they don't hold enough moisture to be able to cause precipitation.
So, Kris, is fog actually a cloud?
That's a great question. Fog is the cloud, right? So fog is actually a stratus cloud that isn't lifted off the ground.
Sorry.
No, that's okay. And so sometimes those clouds that we were just talking about on, I gotta go back to the next one, the previous one. So the clouds that we're talking about on this page sometimes get super angry and they turn into a cumulonimbus cloud. Has anybody seen a big scary cloud like this before? Yeah, Aiden's raising his hand. We've got a couple people raising their hands. Yeah, and sometimes clouds can kind of look angry. They can look scary. And all that is a big cloud that has absorbed tons and tons of moisture. Sorry, the dog behind me is tearing her little animal to shreds. And so these big clouds have just absorbed a tremendous amount of moisture, and they get bigger and bigger and bigger, and sometimes they can produce thunderstorms and severe weather. So I'm going to go to the next slide, and I already kind of gave it away, but does anybody know what this is? Aiden's raising his hand. Anybody else know? Go ahead and say it.
It's a tornado.
Yeah, there's a couple of you that got it. It's called a tornado. You can see how big it is compared to that semi truck there in the picture.
Hey, Daddy. I remember those because we used to watch the Storm Chasers show where they go around in this like heavy armored truck and they find tornadoes and stuff.
Yep. So you know what's interesting is the people who do storm chasing, and sometimes you see them on television shows. Sometimes those people are meteorologists, and a meteorologist is someone who studies the weather to try to notify people when inclement weather or bad weather is going to be coming their way. So in this picture, it is a picture of a tornado. I got to get back on the screen here. And tornadoes don't happen everywhere, right? So you have to have just the right, perfect conditions where you have warm air in clouds and cool air in clouds, and those clouds actually run into each other. And when they run into each other, they start to circle and spin and twirl. And if the conditions are just right, all of that spinning of those clouds can actually produce a funnel cloud, which is a tornado that hasn't touched the ground yet. Or if it comes all the way out of the sky and touches the ground, like the one that we see here in this picture, then that's called a tornado. The National Weather Service can classify tornadoes in severity, just like a hurricane. And we're going to talk about hurricanes in just a little bit. But you can have a class 0 or an EF0 tornado, which has pretty mild winds, comparatively speaking, to a really, really bad tornado, which would be an EF5 or an EF6. It's called the Advanced Fujita. I always get the name messed up, but they shorten it to just say EF, and then they put a number after it. And the higher the number after the EF is the more dangerous and the more severe tornado.
Question.
Oh, go ahead, Aiden.
Trucks and stuff, and they can destroy houses. It's crazy.
Yep, that's exactly right. Someone was asking a question?
Question.
Yeah.
What's the difference between a tornado and a hurricane?
So the difference between a tornado and a hurricane is a tornado is when two hot weather or a warm cloud and a cold cloud collide when they're over land, and a hurricane actually forms over an ocean or a large body of water. So tornadoes, if they form over top of a body of water, they're called a water spout, and they're usually very small and they don't last very long. And a hurricane, which we're going to go to on my next slide right here, maybe.
It looks like Brian's son has a question for you as well.
Oh, yeah.
How do some tornadoes destroy things if it's just wind?
Yeah, well, all right. So if you step outside and it's super windy, right, is it easy or difficult to stand up?
Difficult.
Yeah, it can be difficult to stand up. So now those winds, normally the wind is blowing between 5, 10, 15 miles an hour. So you can usually stand up when there's that force pushing against you. But a tornado has winds that can reach almost 200 miles an hour. So take a race car and drive it down the street as fast as it'll go at 200 miles an hour. What do you think would happen if that race car ran into something?
It break.
It would
Yeah, it would break.
explode.
And so that's actually the force of the wind, right, is over 200 miles an hour, and it's focused in one small spot. So when that wind approaches and it touches a farmhouse or a barn or a building, it actually can knock it over because the building might not be made strong enough to withstand those forces. That's actually how they determine how severe a tornado is based on the amount of damage that it's able to cause, right? So that was a good question. So now on the screen, we've got another severe weather phenomenon that's called a hurricane. And so if you live in Florida or Texas or somewhere on the East Coast, you're going to see them more often than you're going to see them from people who live on the Pacific coast. And that's because it usually forms over a warm body or a cool body of water. And so the Pacific Ocean is actually warmer than the Atlantic Ocean. And so when two large clouds form over, or they run into each other over the ocean, they start to pick up moisture. And the difference between a tornado and a hurricane is just its sheer size and velocity. Because when those clouds are picking up moisture for a tornado, usually if it's picking up that moisture over land, there isn't a lot of moisture to suck up. But if clouds are picking up moisture and it's over the ocean, it has an infinite amount of water that it can evaporate and pull up into its clouds. And so hurricanes can reach hundreds of miles wide versus a tornado. Some of the largest tornadoes ever on record were only about 1.5 to 2 miles wide. And so tornadoes are generally very small and don't have a lot of moisture, and hurricanes can be very, very big and have tons of moisture. Yeah, go ahead. I see you raising your hand.
What happens if a hurricane and a tornado connect?
Oh, that's a good question. So actually, in hurricanes, it's very common that on the edge of the hurricane, so if you look at your screen, I don't suppose you can see my pointer, can you? So on the edge of hurricanes, where the clouds on the front edge of a hurricane, when they come on land, the clouds in a hurricane can actually produce tornadoes. Yeah, so you can have a tornado in a hurricane, but usually those winds are moving so fast and those clouds are moving so fast, it doesn't give the tornado time to form, and the hurricane actually just blows the tornado away. And so hurricanes can be ranked as well, so they have different classifications, and those classifications are based on how fast the wind is blowing within that hurricane. So if you live on the East Coast or Southeast coast in the United States, you're going to see them way more often than you're going to see them on the West Coast of the United States. And the ones that happen on the West Coast in Southern California and going up the coast usually come from areas that are south or southern down by Mexico, and they come up on land from the Mexico area. All right, so these are the last two weather phenomenon that we're going to talk about, and one is a blizzard. Does anybody know what a blizzard is? Yeah, go ahead, Aiden.
It's when like a bunch of snow blows, but way more than the normal amount that would usually fall. It's like, and then there's a ton of it, and it's really strong.
Yeah, so that's actually a perfect answer, because in addition to snow falling out of the sky, a blizzard is usually associated with the wind that comes with it. So when those clouds that I was talking about before are dropping their moisture and it's cold outside, you're going to have a snow event. And usually it'll snow between 2, 3, 4, 5, 6 inches, and that's not a big deal for those of us here in the Midwest. We're used to that amount of snow. But if you get 6 or 7 inches of snow and the winds pick up and they're blowing at 20 or 30 miles an hour, all of the snow that was dropped on the ground starts to blow, and it creates whiteout conditions. It's almost like walking in a fog storm or walking in fog where you can't even see your hand in front of your face because the snow is blowing so bad. And so in order to be classified as a blizzard, you have to have a certain amount of snow along with sustained blowing winds that cause all of that snow to be dangerous because people can't see where they're going. All right, and then the last one that we have up here is hail. How big is that hail? It's pretty big, right? So there's actually a baseball in that picture. Can you guys see the baseball? Yeah. So some of those hailstones are almost as big as a baseball. Can you imagine a whole bunch of baseballs falling out of the sky? What do you think would happen if a whole bunch of baseballs fell out of the sky onto your cars, onto your house? Yeah, go ahead. What do you think?
It
Car
caused
windows.
damage.
Yeah, it's going to cause lots of damage. And so hailstorms can actually be very, very dangerous, right? So we think of a tornado as being dangerous because it can blow your house over. And you think of a hurricane being dangerous because it can have 100-mile-an-hour winds that can cause all kinds of damage and last for a long time. But a hailstorm can be just as dangerous. Can you imagine if you were standing outside and that was happening? That'd be pretty scary, wouldn't it? Yeah. So what we want to do is, as weather spotters, we want to keep our eye out for situations like this. Oh, Aiden, go ahead.
On the Storm Chaser show, they were like in blizzards, and they had to put like on one of those dirt bike helmets just to be safe.
Yep. Yes, they do. Because usually hailstorms aren't associated with snowstorms. Hailstorms are usually associated with tornadoes. And the reason is, if we can go all the way back to those pictures of all of our clouds here, we have all these different kinds of clouds. And cumulonimbus clouds, you see how high it raises way up in the sky? It's super tall compared to the rest of those. And so the higher you get in the sky, the colder it gets. And so if there's a cloud that's absorbing moisture and it starts to drop that moisture, sometimes that moisture gets dropped into another cloud, and that cloud sucks it up, and that moisture turns into ice crystals, and it can go from a low area within the cloud to a high area in the cloud and refreeze and then fall, and then refreeze and then fall, and then refreeze and then fall. And so these little itty bitty ice crystals, as they get sucked back up to the top of that cloud, get heavier and heavier and heavier, and they actually turn into hail. And so hail is just teeny tiny little bits of snow or teeny tiny ice crystals that got pulled back up into the cloud and didn't fall all the way to the ground. And that happens thousands of times until it's finally way too heavy to stay up in the cloud, and it falls out of the cloud as hail. So it'd be pretty scary to have a hailstorm with hailstones this big, wouldn't it? Yeah. Normally when hail falls from the sky, it's little itty bitty ice crystals or sleet, and they're not usually this big. But if the cloud that holds it is strong enough and big enough and high enough in the sky, it can create really, really big hailstones. And so just for this presentation, I looked it up just for grins to see what the biggest hailstone ever recorded was, and it was 8 inches wide. So it's about that big. That'd be pretty scary falling from the sky. Yeah, go ahead with your question.
So what happens if it falls into one of those big clouds and it gets huge?
Well, that's what happened with that really, really big one. Is it was a really tall cloud way up in the sky, and it was a really, really bad storm that had produced tornadoes, and there was lots of moisture, and it just was a hailstone that got brought up into the sky, and they added more moisture to it, and it started to fall, and then it got sucked back up into the cloud, and they added more moisture, and it just got bigger and bigger and bigger and bigger. But that'd be pretty scary to have something the size of a basketball falling out of the sky at you, wouldn't it? Yeah, it would. I see everybody shaking their head. That'd be scary. So that is all I have to talk about for weather today. If I can get to my next slide. Megan, do you want to talk about this?
Sure, I would love to. So today for homework, little kids 0 to 6, I would love it if you would draw us a picture of a cloud of any type or a picture of some kind of weather that you have seen before at your house or maybe while you're on vacation. Big kids 7 to 10, you can draw 5 of the different clouds and label them. You can describe a type of weather you've seen, or you can make a comic about the weather. And middle schoolers, or 11 to 13, you guys can make a comic about several different types of weather interacting together. Maybe they're having an argument or a fight. You can write a paragraph about the weather where you live, or you can draw different clouds and label where they are in the troposphere. So those are our options today. And if you would like to email them to me, I will share them with Kris. And